All right, so let's talk about completing the square. If I have a binomial of the form x squared plus bx, and I add b divided by 2 squared, then this polynomial will factor into a perfect square, okay? So let's say I have x squared plus bx squared. It's going to factor to x plus b over 2 squared. So if I have x squared plus 8x, that's going to factor, and I add 8 over 2 squared, that gives me x squared plus 8x plus 16, and that's going to factor to x plus 4 squared, because 8 divided by 2 is 4. So let's check our answer by FOILing out x plus 4 squared. This gives me x squared plus 4x plus 4x plus 16. So see, we get x squared plus 8x plus 16. If I have x squared minus 14x, I'm still going to add a negative 14 divided by 2 squared. That gives me x squared minus 14x plus 49. And this is going to factor to x plus b over 2. Well, in our case, b is negative 14. So negative 14 divided by 2 is negative 7 squared. So we're going to use completing the square in order to help us factor what were previously prime trinomials. So what do? First, we have to solve ax squared plus bx plus c equals 0. The first thing I need to do is make sure that my leading coefficient is 1. I then need to rewrite my equation so my constant term is alone on one side of the equality symbol. We add b divided by 2 squared to both sides, because remember, what we do to one side of the equation we have to do to the other, because we're working with an equality. Then we're going to factor our remaining trinomial as a perfect square and combine like terms on the other side. So first thing I have is x squared plus 8x plus 10. Oh, and then we use the the square root property in order to find our answers. So x squared plus 8x plus 10. Step 1 is to make sure our leading coefficient is 1. Then I have to move my constant to the other side. Then I have to add b divided by 2 squared to both sides. That gives me x squared plus 8x plus 16 equals negative 10 plus 16. I then know this is going to factor to x plus 4 squared, and I can then use the square root property to solve. So if I take the square root of x plus 4 squared equals 6, I get x plus 4 equals plus or minus square root of 6. So x plus 4 equals the square root of 6, and x plus 4 equals the negative square root of 6. I subtract 4 from both sides. X equals negative 4 plus the square root of 6, and x equals negative 4 minus the square root of 6. So that's how we would solve our first problem. My next example is x squared plus 5x minus 1 equals 0. X squared plus 5x minus 1 is 0. I already see that my leading coefficient is 1. Awesome. I move the constant to the other side. I add 5 divided by 2 squared to both sides. So I get x squared plus 5x plus 25 fourths equals 1 plus 25 fourths. Well, that'd be 29 fourths. and this left part right here is going to factor to x plus 5 over 2 squared. I can now use the square root property in order to simplify this. So I get x plus 5 halves equals the square root of 29 over the square root of 4. Well, that's just 2. But it's got to be plus or minus. So now I can solve. So I've got x equals negative 5 halves plus the square root of 29 over 2, because I added it. And I have x equals negative 5 halves minus the square root of 29 over 2. And I can rewrite these as x, okay, let's move up here. I can rewrite these as x equals negative 5 plus square root of 29 over 2, and x equals negative 5 minus square root of 29 over 2. We can add these fractions because they have the same denominator. If at any point you need to pause to make sure you can catch up with the notes, I definitely recommend something to do to make sure you get your answer correct. Another thing you could do is pause it right after I start a problem, and then you could check your work as you go. So our last example is going to be 2x squared minus 4x minus 5. My leading coefficient is not 2, so I have to divide everything, is not 1, so I have to divide everything by 2. That gives me x squared minus 2x minus 5 halves equals 0. I then go ahead and I add my constant to the other side. So I have x squared minus 2x equals 5 halves. I then add my middle term, b, divided by 2 squared, to both sides. So I get x squared minus 2x plus 1 equals 5 halves plus 1. This is going to factor to x minus 1 squared equals 5 halves plus 1. Well, 1 would be 2 halves, so I've got 7 halves. And then I can take the square root of both sides. X minus 1 equals the square root of 7 halves, so plus or minus. So x equals 1 plus the square root of 7 halves, and 1 equals 1, x equals 1 minus the square root of 7 halves. Now, it says we want to rationalize all denominators. That means we don't want a fraction in our denominator. So let me show you what that looks like. We'll start with this one here. So I have x equals 1 plus the square root of 7 over the square root of 2. So if I wrote 1 as a fraction, I'd have x equals square root of 2 over square root of 2 plus square root of 7 over the square root of 2. So x equals the square root of 2 plus square root of 7 over the square root of 2. And then in order to get the square root of 2 out of the denominator, I multiply by square root of 2 on the top of the bottom. That gives me x equals square root of 2 times the square root of 2. That gives me 2 plus the square root of 2 times 7. That's the square root of 14 over square root of 2 times the square root of 2 just gives me 2. So then this would also, I do the same thing, and I get x equals 2 minus the square root of 14 over 2.